The next most important topic in real time also, mostly we are using on tables, that is called data integrity. We called data integrity. The first of all, we should know that what is the meaning of data integrity here. Okay. So what is the meaning of data integrity? And later, okay, how many types of integrity mechanisms are okay we have here in database? What are those? Those mechanisms implement tables. Okay. So these all kind of informations we can see under data integrity mechanism. So data integrity is one of the most important topic in database. And why, sir, this is an important topic? Automatically, you will be knowing. Okay, na? Right. Let me come out and see. I will go for this. Okay, I will go for this. So first of all, the data integrity is nothing but, guys, here. First, remember, what is the mean by data integrity means? Your data integrity is nothing but to maintain accurate information, guys. You know, to maintain accurate information. Okay, now. Okay, how it was using, okay, in my databases means. So for example, let me go to your database now. Okay, I'm going to clear my screen now. Okay, right. And now I'm going to create one sample table. Just observe, creating one sample table. So my table name is, for example, employee is one of the table I'm creating. So employee ID number, and the next one is employee name. Okay, and the next one is salary, employee salary. Okay, and next we will go for employee age also I'm taking now. So this is what we called as, guys, here. Okay, so to executing of table, that's fine. But can you tell me on this table, can you tell me on this table, I was applied any constant here, like any primary key constant, any foreign key constant, that kind of any constants you applied on your table? No, we are not applied any kind of constants here. Yes or no? We are not applying. Just a normal table I'm creating. That's it. I'm creating a normal table, but I didn't apply anything now. Okay. So, okay, fine. So whenever you want to design your tables or created your tables like this, then what it was happening, you can see. Suppose are you inserted some data now? I want to insert. Insert into my table name is employee, sending values of employee ID number, employee name Smith, employee salary 25,000, and employee age was 24. So this is my first record. I'm going to insert it here. Okay, now let me find the first record. As usual, it was successfully inserted into my table. There is nothing problem here. Now, whenever I just come out and call my table, okay, that employee, what it was happen, your data will be showing us. Okay, fine. But my point is what now, guys, here, suppose I'm going to send in the same information next, that means one more time I'm inserting here. So one more time I'm inserting here. So can you tell me the same data which is already existing in my table, the same data which is already existing in my table, same data one more time I'm inserting. Can I insert now? Come on, guys. This is, can I insert now? Is it allowed? So now, can we insert? Yes. Now you can see what it was happen if I execute this one. Okay. If I execute this one, what happened? You can see allowed. And the same information one more time inserted, allowed. So how many times are you inserted the same data? The data is successfully allowed into your table. And finally, when you come back to my table employee, can you see? So the same information 3 times I saved in my table. But just think about Is it necessary to save your data like this in your tables? Come on, guys. Is it any necessary here? No, it's not necessary to save my data like this. Okay, but still it was accepting. And why should I want to save that data? This is duplicate data now. Is it duplicate or not? Yes, it is a duplicate data. And if you store like this, there is no use of, okay, there is no use, nothing, but unnecessarily we are wasting our memory also. Okay, na? So this is what it was happening. And one more problem is observed. Suppose, guys, if I'm inserting empty blocks, I'm giving some empty blocks. Can I insert this empty block? Yes, we can. And the same empty blocks one more time, can I insert here? Yes, we can. So later, after that, you can come back and see your table. Yes. So your nulls also allowed. Nulls also successfully be inserted here. Nulls. That is one thing. Suppose one more thing. Okay, if I'm inserting here 1022, the name is Ellen. Salary was 1 rupee salary. Year, age was 36,000 years of age. So here, what I'm doing, guys, here, carefully, if you see, employee ID, I'm sending 1022. Employee name is Ellen. Employee salary, I'm sending 1 rupee. And employee age column, I'm sending 36,000 years of age. 36,000 years of age, I'm sending. Is it accepted now? Can we accept 36,000 years of age? Is there any human being? No. So that means that this data is a valid data, na? It is a valid or invalid, guys? Is it valid or invalid? Which one is this? Valid data or invalid data? This is not valid. This is invalid data. Now tell me, invalid data, you want it? You want to accept into your table? No. Okay, na? We don't want it. So why should I want to accept invalid data? There is no use. But what it was happening, you can see in this case, if I just execute, it is also accepted. See, the data is a valid, invalid, none of the matter. But your table is accepting that data also. Can you see here what happened? Okay, so duplicates are accepted here. And 2 nulls, empty rows are created here unnecessarily. And 36,000 years of age also allowed. Understand my point now? Right. So that means, now tell me, in your real time, okay, in your real time, if are you designing and created this kind of table in your real time, in your real life, okay, in real time, tell me your client is accepting this table or not? Anybody accept this table in my real time? Your clients are accepting this table, whatever you created now? No, no one can accept this table. Okay, no one can accept this table. Okay, so when you design your tables in real-time applications, this table no one accepted. Your tables will be rejected by client. Your tables are rejected by client. Okay, now we cannot. So why, sir, it is rejected means, yes, in this there is so many problems are there. Okay, now right. So what it was happening here, what it was happening in this table, we have a problem. What kind of problems we identified? First, data redundancy problems are there. Data, redundancy, okay, table is there. First thing. Redundancy means duplicates data. Second problem is what now? Unnecessarily we give it as some gaps in between rows. That is called as a nulls. That is called as a nulls. Third one is what now? If any unnecessary or invalid of data, user fortunate or unfortunately, he was inserted into your table, that okay, invalid data is also accepting. So finally on this table, redundancy problem, nulls problem, and data invalid problem. That is say invalid of data acceptancy problem. Okay, now. So now tell me, if your table, whatever the data showing this data is called as a accuracy or no? Your data is accurate or not? Your table information is accurate or not accurate? Yes, not accuracy. Not accuracy. So that's why this kind of tables are your clients are rejected. Okay, now. So now what I want to do, sir, how I want to design my tables means, sir, first thing is when I design my table, okay, duplicate problems first I need to avoid. If any user, either fortunate or unfortunate, he try to insert some data into my table, that should be accept only unique data and don't allow the duplicate. That is one thing. Next, nulls also not allowed. Why are you allowed nulls? If you are allowed nulls, the gapping is coming out. Gap is come out in between rows. That's also not good for us. Next, invalid of data. Suppose user, fortunately, he was inserting some invalid of data. That invalid of data also immediately I want to restrict it. Immediately I want to restrict it. Understand now? So how I can do these all kind of operations on this table? Okay, how I can do this all kind of operations on this table means there is a one mechanism is there. That mechanism is called as a data integrity mechanism. So now finally, what is data integrity? If anybody asks you, you can say data integrity is nothing but to maintain accurate and consistency data in database tables. To maintain accurate and consistency data in database tables. Okay, now. So consistency means what now? The data should be regularity, not irregular data. Not irregular data. Data should be regular format. Okay. Accuracy, exactly data without mismatching duplicates. Okay, accuracy. So now this is what. Okay, now right. And this data integrity will be two types of the mechanisms here. One is we called as a procedural data integrity mechanism. Procedural data integrity. This is one way. And this procedural integrity mechanism, okay, it can be implemented. Okay, it can be implemented by using one of the concept. The concept is called as what now? Constraint. And this is the part of SQL language. Okay, constraint is one of the topic of SQL. And the second one is called as here user defined data integrity mechanism. So this can be implemented by using of one of the most important concept, triggers. And this trigger is a concept of a PL/SQL language. Okay, now, so that means triggers concept we will see in the next second part. In second part, I will show you what is trigger. And in this part, we will discuss about constraint. And next we will go for triggers. And finally, comparing of these two, and you just observe what is the differences of constraint and trigger. Okay, now, right. But first we will go for what is this procedural integrity mechanism we need to implement. Okay, right. So, and the second one I will show you in the second part of Oracle. So procedural data integrity. Procedural data integrity in this category or in this, okay, the classification, there are three types of, again, it was classified. One is called as a entity integrity mechanism. Second one is called as here referential integrity mechanism. Referential integrity mechanism. And third one is called as here, okay, domain integrity mechanism. Domain integrity mechanism. Okay, fine. So now first we will discuss about what is entity, what is referential, and what is domain. Okay. Now first one we called as entity. So entity integrity mechanism. Okay, what it mean? What it mean? It means that okay, your entity is nothing but table, guys. Here, carefully observe. Entity is nothing but table. So in your table, each and every row should identified with a unique number. Okay, now should identified with the unique number. Okay, so what it mean? Okay, now what it mean? Observe what it mean. Okay, so for example, I'm designing one table. I'm designing one table. In this table, I designed some columns now. Okay, this is my table T1, and some columns I'm taking here. For example, employee ID column, employee name column, some salary column. Suppose on this table, if you're not applied any constraint here, okay, then what it was happening, you can see. One second, guys. Okay, right. So now here, what I'm saying here, suppose this is your table. Okay, this is your table. So in this table, I'm creating three columns, table one, and it is ID column and the name column, for example. Okay, and this is salary column. So what I'm saying, guys, here, suppose you didn't apply any constraint, okay, on this table, okay, na, any constraint on this table, you didn't apply. Then what it was happened, suppose I'm inserting some row. The ID number one, some name, some so on so salary. This is first row. Suppose I inserted my second row two, the name is B, some salary. This is my second row. If I inserted three, C, some salary. Okay. So now we are see whenever you can go to this table, how many rows we have here? This is row number one. This is row number two. This is row number three. Understand now? The three rows are there here. So three rows we have it here, right? And each row, okay, suppose if you see one of my column, ID column, you can see 1, 2, 3. That means in this column, do you have any duplicate values? No, there is no duplicate values. So now this kind of maintenance is called as a entity integrity, we call. Understand now? This kind of maintenance is called as a entity integrity, we call. And suppose, for example, let you go. Suppose, okay, these are the three rows. Okay, now next I'm going to inserting one more row here. The next row D, some salary, and I'm giving here, for example, 2 I was given. It is also accepted. Now, how many rows we have here? Row number 1, row number 2, row number 3, row number 4. There are 4 rows. But in the 4 rows, first row is okay, second row okay, third row okay, but fourth row is not okay. Why? Because the fourth row number 2 already existing in my second row position. That means, can I say it is a duplicate? Come on, guys. Okay, now then what we say, then it is not a entity table. This is not satisfied entity integrity. Got it my point now? Got it all of you? Yes. Okay, now so that means finally, how can you define this? Entity integrity is nothing but okay, in a table, okay, or else each row, I can say it ensure that each row in a table should be unique. Your unique is nothing but what now? Different. Your unique is nothing but what now? Different. Okay, now right. So that is what we called as the entity mechanism. But sir, how I can maintain this each row in a table should be unique means or unique identity means yes, there are some keys are there. Okay, that key is what now? First one, unique comma primary key. These are the two constants we have here. Okay, so by using of unique and primary key, I can implement my entity integrity mechanism. Understand now? So that means what I'm doing here, same thing. Let me see. Same thing. If the table, 3 columns, ID column, name column, salary column, T1 table. Suppose in this any one column, you decide as per your requirement in which column I want to apply my unique constant or primary key constant. So based on the user requirement basis, it will be decided to where I want to apply. Suppose I'm deciding here ID column. So on ID column, you can apply unique constant. Otherwise, you can apply primary key constant. So whenever you applied these constants on particular column, then this column is called as what now? Key column we called. It is called as what now? Key column we called. Key column means what now? Main column. Identity column is called as a key column. So when this is a unique or primary key, okay, this is called a key column. Then what happened? If user inserted 1, A, some salary, accept. If user inserted 2, B, some salary, accept. But whenever user trying to inserted again 2, C, it was what happened? Immediately it was showing some error. Because of reason, unique constraint, okay, because of reason, unique constraint, primary key constraint, not allowed duplicate data. My point is got it now? Unique constraint and or primary key constant will not allow to duplicate data. So that's what it was happen. Each and every row data should be in the unique manner. So that means it should be 3. 3 is allowed. 3, C, and some salary allowed. So now what happened? Each row is uniquely identified now. So this is unique number. This is unique number. This is also unique number. Then this will be satisfied entity integrity mechanism. Understand now? Yes, this is what we called as a entity integrity we called. Okay, now, and that can be entity integrity can be implemented with which constraints, unique key and primary key. Understand now? Right. Now, next one is what now? Second one is what now? Referential integrity. Referential integrity. What is referential integrity, sir? Okay, now what is referential integrity? And this integrity, how it will be implemented? How it will be implemented means here observe referential integrity mechanism. Okay, it is used for to make relationships, between tables. Okay, na? So whenever you want to making relationships in between table, okay, na, then it is called as what now? Referential integrity we called. Then it is called as what now? Referential integrity we call. So now you are asking some question, sir, why should I want to making relationships, sir? Okay, na? So why the relationships? Why we want to make in between tables? This question will come to you. So many people have a doubt also. Why, sir? Why we want to create a relationships in between tables? Is there any reason behind that? Means yes, have some reasons. The reasons how, okay, what is that reason why we want to create it? That I will give some example. Okay, na? Along with the practical example, I will explain. Okay, na? Then only we'll get some idea. Right now. So this is the purpose of referential integrity. And referential integrity, okay, how I can implement it means, here one of the constant I'm using here. So by using one of the constant is called as what now? Foreign key constant I'm using. Here I'm using what now? Foreign key constant. And here we are using unique constant and our primary key constant. Okay, we are using these constants here. Okay, na? Right. So here I'm using foreign key. Compulsory we should require foreign key to making okay relationships in between table. But why relationship? What is a relationship? That all I will explain to you along with example. Okay, na? Right. And the next one is third one is called as what now? Domain integrity. So what is domain integrity? What is domain integrity? Here carefully observe. In database, okay, in database, what it was happen? A domain is nothing but column. A domain is nothing but a column. So that means in my table, every column will treat as a one domain. Every column will treat as a one domain. And into this domain or into this column, if user inserting some values, those values we need to check. Okay, for example, can you see here 36,000 value I'm inserting into age domain column. I inserted. But what it was happened, this is allowed now. Come on, guys, it is allowed or not? Yes, it is allowed. So, but I don't allow this actually. Okay, I don't want to allow this, but it is allowed. Okay, so this kind of a verification, that means here what happened, data is not verified actually. Yes or no, 36,000 is allowed into age column. Okay, how it was allowed means your Oracle server is not verified your data. Your Oracle server is not verified your data. So data is not checking. That's why 36,000 is allowed. But if you allow like this, that is not an accuracy. Okay, na? That is not a consistency. So to overcome that problems, okay, what we are using here, we need to apply some restrictions now. Okay, how I can apply? For example, you can see, are you created one table? Okay, so it's some columns, ID, name, and here age column. Okay, now. So now on this age column, this is called domain 1, domain 2, domain number 3. 3 domains are there. So one of the domain age domain is there. On this age domain, I will apply one constraint. What is the constraint? Check my age between okay 1 to okay my age between 1 to 100 I was given. Okay, now my condition I was applied on age column, my age between 1 to 100. So 1 to 100 means what happened? If suppose user is inserted 25 years age, then this age will be accepting a yes, allow. If user inserted 45 age, this is also allowed, nothing problem, because your condition 1 to 100 now. Suppose user is inserting 99,000. Okay, this is also allowed, 99,000, satisfied. Suppose user is inserting 100. 100 is also satisfied. But whenever user is try to insert 101, so 101 is allowed or not allowed? Because my condition, how much I was given? 1 to 100 years only I'm giving. If user sending 101 age, immediately restricted or stopping that kind of data. Okay, now, so this kind of checking, verifications, or checking the data, validating, data validation we called. So that kind of validation mechanism is called as a domain integrity we call. Understand my point now? So domain integrity we call. So that is finally what you say domain integrity. Domain integrity is nothing but, okay, domain integrity is nothing but here to check values before accepting into a column. Before accepting into a column. Okay, now how I can do this? There is some constraints. So there is some constraints. That's called by using check constraint. Okay, by using of a not null constraint, by using of a default constraints. So these are the constraints which will be applicable on domain integrity mechanisms. Okay, now. So these are called as a three types of entity, referential, and domain. And each integrity mechanism we will be implemented by using of some constants keys are there. Okay, now. So let me find out here. So here two keys are there, unique and primary key. Here one is there, foreign key, and here check not null default. So what are these, sir? These are called as a constants we call. These are called as a constants. And these constants, user defined, these constants we created. Come on, guys. These constants are we created, or else these are predefined. These are predefined we called. It's not our creation, already inbuilt keys we called. So this is called as a procedural integrity mechanism. Procedural integrity means what now? Predefined integrity rules. Okay, now these are called as what now? Predefined integrity rules we called. That is called a predefined procedural. Procedural means what now? Predefined. Sorry guys, a small mistake is done. Actually, procedural is not a predefined. Okay, just wait. This is called as a declarative. Actually, declarative is called a predefined. I just change this. Sorry for the statement. Declarative. Yes, declarative. This is okay. This is predefined. This is procedural because user defined. Procedural means user defined. Procedural integrity. Okay, so here I want to change declarative. Okay, na? Right. Declarative data integrity. Yes. So declarative data integrity. So three types here, and whatever the keys I'm using here, okay, these keys are inbuilt keys. Okay, and then we called as here. Okay, this mechanism is called a predefined integrity rules we call. So every constant is a one rule. Primary key is one rule. Okay, foreign key is one rule. Unique is a one rule. Not null is a one rule. Check is a one rule. Yes or no? So these rules are inbuilt. So that's why we called as a declarative. And procedure means what now we can understand. Procedure means what now? User defined. So user defined, that is called a procedures because user is created here. These rules are created by user defined. Okay, now these are called as a predefined. Predefined. Okay, fine. So these are the two types of integrity mechanisms. Okay, now and finally come back here. So these all constants you can see finally. What we can do means these all to implement here. If I want to implement my Okay, which integrity mechanism? Declarative. Okay, in this declarative data integrity mechanism, if I want to implement, then I want it what now? Constraints. So finally, constraints what it is. Okay, finally, constraint what it is. So now, can you check here in this all keys, whatever I'm using, guys? These all keys, the conclusion. What is the conclusion of this keys means? These all keys are we are using for, that means constants are used for, constants are used to restricted is a very important pointer. Okay, restricted, otherwise enforced, otherwise enforced. Okay, so restricted unwanted data, restricted unwanted data into a table. Understand my point now? So all constant, I will show you practically, you can understand that, no problem. So these constraints, foreign key and unique primary key, finally, these all are concluded. What purpose I'm using these all constants on my table means to restricted or enforced unwanted data. To restricted or unenforced unwanted data. That is the main purpose of these constraints keys. Okay, and these are how many types? Okay, total 6 types. First one, unique. Second one, not null. Third one, check constraint. Okay, fourth one, primary key. And fifth one, foreign key. Okay, and next default. Okay, now, so these are the total 6 constraints we have here to maintain, okay, accurate and consistency of data. That's called as a to restricted or enforced unwanted data. Got it my point now? Yes. And here we will discuss. Here we will discuss what is unique, what is not null, check, primary, foreign key, default. What are these and how these constraints we need to apply on your table. Okay, now that practically I will show you each and every constant, how it was working on your table. Okay, that we will see some practical examples. Okay, now, right, guys. And those examples, those things we will be implemented tomorrow. So tomorrow I will implement each and every constant here, how we can use. Okay, now, right. So I stop it here. And